Okay guys, we are going to look at standard forms of equations, of linear equations. We're going to focus all of our efforts and energy on linear equations for this particular unit. So we're going to draw nice straight line graphs. So we're going to look at the standard form first. Looks like this. Now you'll notice there's an x in the equation. What's important is to realize that x does not have an exponent, so that is how I know that it's definitely going to be a linear equation. This a and this b and this c, these are just numbers. That's just nothing more than real numbers, usually integers, but could they be fractions and decimals? Absolutely, positively. So what we want to be able to calculate today, in order to be able to graph and such, is we're going to calculate some solutions to the equations. And these are ordered pairs. Of course, all ordered pairs come in the form x comma y that make the equation true. And we've done this with other things, so this shouldn't be too much of a stretch. So we're looking for ordered pairs that make the equation true. Notice again we needed an ordered pair because in our standard form or our form of linear equations we don't just have x's now, we have x's and y's. So a nice equation in standard form, x plus 2y equals 5. I just want to test to see, is the ordered pair 1, 2 a solution? Does it make the equation true when I plug it in? So again, an ordered pair is an x and a y. All I'm going to do to check that is I'm going to substitute. I'm going to replace the x in the original equation with a 1. I always like to put my substitutes in parentheses because now I know I multiply those two things together. And all I'm looking for is to see, does this side equal this side? If they equal, it's a solution. Order of operations, I do multiply before I add, and then 1 plus 4 is 5. Hey, that's a true statement. So we can say that 1, 2 is a solution to the equation. Oops, I'm out of the screen. So now we'll check 7, 3. Same process. This is your x value, this is your y. So 7 plus 2 times negative 3 equals 5. Same order of operations, multiplication before addition. That gets you a negative 6. And last time I checked, 7 minus 6 is 1. And 1 does not equal 5. So we would say 7 negative 3 is not a solution. Now, why are we actually checking for solutions or not a solutions? Because if a point is a solution, it's actually going to be on the actual line of this particular function when we go to graph it. If it's not a solution, this ordered pair is not going to be on the line. So when we move down to number 3, and I want us to find 3 ordered pairs that are solutions, well, I'm not going to randomly guess. I'm going to calculate them. And how we're going to do that is we're going to make a little table of values. So I'm just going to make a nice XY chart. And I'm going to choose 3 values for x. Now, according to the directions, it says choose at least 1 positive and 1 negative. And then I'm going to write my solutions as ordered pairs. Now notice I'm not choosing the y values, I'm going to find the y values. So if I choose my favorite number, 0, all I'm going to do is go to my equation. I'm going to replace the x with the 0, and I'm going to solve for y. And it will tell me which value of y has to go with x equals 0. So essentially you're looking for your y values. So when x is equal to 0, y is equal to negative 1, and those two numbers together make up the ordered pair, and that ordered pair is a solution to that particular equation. Now, I could have got real fancy if I wanted to, because remember, I could change y to f of x, because we know we can do that. And that's the same as me saying f of 0. So when x is equal to 0, y is equal to 1. So we're just going to repeat that process for 2 more values. Well, I picked 0, so let's pick a negative number, maybe negative 2. So go to my equation. Wherever there's an x, I'm going to replace it with a -2. Order of operations, +4 minus 1. Y is equal to 3. So when x is equal to -2, y is equal to a -3 for this particular linear function. All right, I'm going to pick a positive number. So y equals -2, 3 minus 1. And I could have picked whatever numbers I wanted to, and you'll have the option to pick whatever numbers you want to for other things. And I see that if y is, or x is equal to 3, y is going to equal to -7. But if you picked these values and you did not get these numbers, then something went wrong in your calculation, because there is only a specific y value that can match with 0, and only one specific y value that match with -2, and only one value that should match with 3 for this particular equation. And those are your solutions. So same thing, I'm going to pick a few. I'll get you started. Pause the video afterwards, get your answers and see if they match mine, and then start the video back up again. So we're going to find 3 ordered pair solutions. So of course I'm going to start with my table, and just so that we're all getting the same values, let's pick some different numbers. I'm going to pick -5, 0, and 4. All right, hit pause, find those y values, and then once you've got your answers, check back and see if you're correct. All right, let's see if you got the same values that I did. Just to show you, you can get negative numbers, you can get fractions, you can get decimals. It's fine. If those values are your solutions, then those are your answers. We might not get pretty numbers, and it's perfectly okay. So you can see my work where I substituted in the -5. You can see my work where I substituted in 0. And then I was running out of room, but you can see my work where I substituted in a 4. Okay. So we're going to take this idea of these tables and these solutions, and we're now going to represent these solutions graphically. So they're in a table form. We've used the algebra to get it. So now let's put them in graph form. So if you notice on the back, I've got myself my linear equation. Again, I can recognize that because x does not have an exponent. And I've got my table. I've given you which values I want you to find. So all we're going to do is find the y values that match that. So same process we just did. So every time I see an x, in this case I'm going to replace it with a -2. If we need our calculators, no big deal, that's what they are there for. 1/2 times a -2. That gets me -1. And so y equals -4. Now the only difference is now I'm going to represent this point not only in the table, but I'm going to represent it as a point on the graph. Remember your ordered pair at -2, -4. We always start at 0, 0, go to the left 2, and then down 4. There's my point, -2, -4. So now I'm going to repeat. 0, isn't it great? What a great number. Wipes out the 1/2. That gets you 0 minus 3. And now I've got a new ordered pair. This is a solution. So I come over here. 0 means don't go left or right, but now we go down 3. Now what you should notice is there's going to be a pattern forming with the points that we are plotting. 1/2 times 4 is 2. 2 minus 3 is -1. So 4, -1 over 4, down 1. Now if you notice, my points in my graph are not scattered. They actually form a straight line. They should, because remember our function is linear, our points should be linear. So we're going to take a straight edge. You could use the edge of a notebook, a ruler, a note card, and I'm going to draw a line that goes through all of those points. I'm going to put arrows on the ends of those lines. That indicates that even though my graph ends, or my coordinate plane ends here, the graph continues indefinitely from -infinity to +infinity in both its domain and range. Now, if you go to plot your points and your points do not end up in a straight line, then you miscalculated something over here. So, values for x, calculate to find y, those produce ordered pairs. These ordered pairs are specific solutions to this equation. Graphically, we plot the points. The points should connect in a line. We draw a line between them. So those 3 points are not the only points that are solutions. The line represents all of the solutions. So every point on this line represents a solution to that equation. All right, I'm going to have you work on these next few. I'm going to do the work. I'm not going to go through and video it. You are welcome to pause and then come back and see if you got the right answers. Let's see if you've got the same values in your table. We substitute the values into our function. Same notation, different notation, but it's the same idea. You know, we're just finding y values. So again, f of 4 just means what's y when x is equal to 4. Oops, negative 4. Now that I see that. Good thing I wrote it correctly here. And when we graph it, again, if your points do not end up in a linear pattern with 3 points in a straight line, something went wrong in your calculation. Take a straight edge, connect those points in a continuous line, arrows on the ends. And then there's the ones for 7. I do 3 points because 3 points will usually catch an error. 2 points we definitely would never catch our error. And those what your graph should look like. All right, be ready to do this in class the next day.